Hi, my name is Liam Hanna, and I'm the technical specialist for the Inuktun portfolio of Edify Technologies, looking after the EMEA. Recently, Edify Technologies were asked to assist in a trial to visually inspect the interior of a pressure vessel with CAN Offshore in Aberdeen, UK. For this trial, we had to consider the mechanical restraints of size, shape, and of course material to determine just how we could approach this inspection and operate within this environment in order to obtain not only good relevant images, but to operate as efficiently as possible without damaging the asset or the robotic equipment deployed. From the beginning, it was important that we considered not only how to capture images inside this vessel, but how we could obtain as much information as possible throughout the course of the inspection, and then present this in a way that would give an asset owner all of the information that they need to make the best, most informed decisions. By creating a photogrammetric 3D model using the image data collected during the inspection, we are now, for the first time, able to achieve our ultimate goal, and this is to provide a permanent record of inspection by means of a digital twin. Something that lasts forever and allows the asset owner or decision maker to step into their asset and see and manipulate for themselves data on a level that could not be provided or absorbed with single images inside a report. It's important to consider the material that the vessel is made out of and the shape. I mentioned this is a relatively small vessel, so therefore we needed a relatively small robot to be able to crawl around the inside of the interior of this vessel. The robot is attached to the top of this vessel magnetically. We've got some rare earth magnets on the inside of the chassis here, and that provides the magnetic force to keep the robot in contact with the vessel wall. So it took about 2 hours to gain the images we needed. We took around about 900 images throughout that period of time, and all of these images are taken and stitched together to be able to form this initial 3D projection, this internal projection from the inspection environment itself, to give you some context to actually where these images are taken and what it looks like. We've done this using only a camera. There's no other technology attached to this robot to create this information. There's no requirement for encoders or anything like that, even though there are encoders on the robot. We're purely looking here at image data. We've taken the contrast from that, and then this has been in software stitched together, and this 3D rendering is formed. Now you can get information such as line of sight, and the polygons here show where the robot was when it took the various images, and then you can apply some real texture, so you can get a photographic overlay to be able to really step inside this vessel and see what it looks like in real life. You can manipulate this and move closer. We'll see that very, very shortly. And ultimately you end up with a nice 3D model of your asset, which you can use to keep on file for condition monitoring purposes, to revisit, to have second opinions from various different people if you need to. But most importantly, if you have an image that's been taken in a specific location, historically you would put that in a report. Now it's almost impossible to work out where that image was taken if there's no data backing that up. And even if there is, if you look at a vessel and an image from inside that vessel, there are hundreds, if not millions, if not infinite amounts of locations that actually would look the same as where that image was taken. So when it comes to finding an interesting point, an interesting location, or indeed a defect, and you want to take an image of that, then it's really important that we understand where that's taken. And at the moment, the only real way of doing this is by creating this digital twin, this permanent record of inspection. And you can see from this output render received by our good colleagues at CAN Offshore that actually this is exactly what you get. You've got the ability to look at all of that data. So we purely just took some images here. There's nothing more than images that have gone into creating this. But rather than just having an image in a report, you've got the ability to still use those images, but also create this 3D model. Now this 3D model, you can manipulate, you can move this around, and you can look at this from different areas, different aspects. Remember, inside this 3D model are still thousands of images that you can click on, and it will show you the exact image from an exact location, which means that you can actually get some really good contextual data. Now, I mentioned contextual data earlier. That's really important because actually just seeing a defect doesn't really mean anything without having something to check that against. Now, you can look at a defect, you can see if it's a problem or not, and then you can actually revisit that at a later date to see if it has changed or if it has grown. But most importantly,
you know exactly where that was. So when it comes to looking at it next time, you've got the ability to go back to the exact location or the real place in time. There's no guesswork associated with, here's an image in a report and it was taken in this vessel somewhere. This permanent record of inspection, this digital twin, gives you much better understanding of your asset and the ability to make decisions when it comes to, is this asset okay? Do we need to inspect it again shortly? Or do we look at this in a different way?
So in closing, if we compare the old way, lots of images and reports, to a new way, a permanent record of inspection, a digital twin that lives forever, it is evident very quickly that this access to real-time data gives much more context, not only to an inspection service provider, asset owner, or decision maker, but allows for mitigation against misinformation. The increased probability of detection means that it is less likely to miss a potential defect or area of interest, and the knock-on effects of speed of inspection and post-inspection analysis should translate into direct cost savings. Considering this commercial element, with the increased quality of inspection and the ability to revisit the asset indefinitely from the safe environment of your own home, your car, a hotel room, or any other location that isn't associated with physically revisiting the inspection site, it is clear that this is a very real solution that allows for immediate integration to our processes and workflow. What does this mean for the industry? Better control over condition monitoring, greater transparency, and perpetual access to the best information, allowing an asset owner to make the best, most informed decision. So thank you very much for your attention over the last few minutes. If you have any questions or you'd like to discuss any of these topics or other robotic related topics any further, then please don't hesitate to contact me directly through Spring Robotics or on the Edify website.